In this video, we are going to look at decimal representations of rational numbers. Rational numbers are nothing but the ratio of two integers. So, two integers p divided by q. P by q is a rational number. So, this itself says that p can be divided by q, isn't it? And in fact, we have a video in our own channel all about decimals. The link of this video I have provided in the description below. The video gives a clear intuition of dividing two rational numbers to get their decimal representation. This is in our real numbers playlist. Please watch the video to get more intuition about representing rational numbers as decimal representations. So p divided by q, both of them being integers, we can follow the long division method. It has to be modified slightly to get the decimal equivalent. So let us take few examples and divide and find the decimal representations. The first one, let it be 7 by 8. So let's divide 7 by 8. 7 is smaller than 8. So at once you will have to add a 0 to 7. 8 8's 64. 6 is the remainder. Adding 0 to the right, you get 8 7's 56. 4 is the remainder. And adding a 0, you get 8 5's 40. So there is no more remainder now. The remainder is 0. So 7 by 8 can be expressed as 0.875. The decimal representation of this rational number 7 by 8 is 0.875. Now let's divide the same 7 by 6 and see what happens. So you're dividing 7 by 6. 6 1 6, because 7 is of course bigger than 6, so 6 ones are 6 and 1 is a remainder. And now we'll have to place a decimal because 1 is lesser than 6. Add a 0. Once again 6 ones are 6, you get a 4 as a remainder. So putting a 0 to the right, you get 6 6 36. Once again the remainder is 4. So now this step is going to continue forever. You'll be getting 40, you'll be putting another 6 in the quotient, 36, and once again the remainder is 4. So this is going to repeat forever, or in other words, 7 by 6 is equal to 1.166666, and the 6 goes on forever. A simple way to represent this repeating decimal is putting a bar over the repeating number. So 6, the bar over 6, to show that 6 is repeating. So this decimal 7 by 8, we found that it was terminating. It was terminating. And whereas this one is non-terminating. This is non-terminating. And it is also recurring. Now let's see one more example. Let us look at this rational number 1 by 999. So how will we divide this? We have 1 and you divide it by 999. So of course place a decimal because 1 is much lesser than 999. Add 1 0, not enough. Add one more 0, not enough. And one more 0, you get 999, ones 999. And once again you get a remainder of 1. So this process is going to continue now, isn't it? You're going to add 3 zeros. So you would be getting once again 0, 0, 1, and the process is going to continue, right? So this is also an example of non-terminating recurring. So now we have two types of decimals we have seen here. Let us try to classify them. Decimals can be terminating. This is the first one we saw in the case of 7 by 8. And it can also be non-terminating. And in this case, it was recurring. isn't it? It was recurring, that is repeating. It was repeating. So now, since we have familiarized ourselves with decimal representations of all available rational numbers, p by q, you may also try on your own. You take any fraction, any p by q, negative, positive, and try to find the decimal equivalence. Of course, you will get something, isn't it? So now the question arises, what is left? Isn't it? We have terminating, we have non-terminating. In decimals, we have classified them by dividing rational numbers, the p by q form, the fractions. So, if any fraction could be represented as a decimal, if any fraction which we could think of could be represented as a decimal, it leaves us wondering, can any decimal which one could think of, be expressed as a what? Rational number, isn't it? Be expressed as a fraction at least. So this is the question which is in our minds now. Having done the decimal representations of all fractions, can any decimal which one could think of be expressed as a fraction? Now we will have to explore this question. You also think about it, and we will explore about it in our next video. Till then, thank you.